Hi everybody, today we're talking about directed graphs. To help us get started, let's look at a definition. A directed graph, also called a digraph, is a visual representation of a relation on a set. Each element of the set becomes a vertex, and each ordered pair AB in the relation becomes a directed edge from A to B. We can break that down into a number of steps. Step 1 would be to draw the vertices. These are just dots or circles representing elements of our original set. Then we add in the directed edges. These are arrows from element A to element B for each ordered pair AB in the relation R. When we have an ordered pair AA, we call this a self-loop. It's an arrow from a vertex back to itself. As we're drawing, it's important to remember that order matters. AB and BA are different edges with opposite directions. When we're drawing, we are always going to start by identifying the set, then we'll draw the vertices, list the ordered pairs, and then draw the directed edges. Our first example is the relation R that's composed of ordered pairs 1, 1, 2, 2, 3, 3, 4, 4, 1, 2, 2, 1, 4, 3, and 3, 4 that come from the set A, which is equal to 1, 2, 3, 4. As we begin to draw the graph, we want to look at the set A having 4 elements, 1, 2, 3, 4, separate from the relation R that's composed of the ordered pairs. This way, we can draw our vertices in the graph. We'll make a circle for each of the elements, remembering to give ourselves spaces to add the edges as we go. In this graph, we'll have 1, 2, 3, and 4. Now we're ready to add some edges. We're going to start with the self-loops. We have 1, 1, 2, 2, 3, 3, and 4, 4. So we'll have a loop at 1, a loop at 2, a loop at 3, and a loop at 4. Now we can add the remaining edges. We're going to start with 1, 2. We're going to draw an arrow from the vertex 1 over to 2. Next, we'll draw an arrow from 2 back to 1. Then we'll add in edges for 4, 3, and 3, 4. That means we're going to go from 4 to 3, and then from 3 back to 4. Because we see arrows in both directions, we often call this biconditional. You have a choice to either leave 2 edges with the 2 directed arrows, or you can replace it with a single edge with double arrows. So we could take away 1, 2 and 2, 1 and put a double-headed arrow. We can take away 4, 3 and 3, 4 and put a double-headed arrow to show the relationship goes in both directions. Our second example is a little more complicated. We have the set A is 1, 2, 3, 4, but this time the relation is less than or equal to. That means we want to find all ordered pairs AB where A is less than or equal to B. If we start with the number 1, we'll have 1, 1, 1, 2, 1, 3, and 1, 4 because 1 is less than or equal to all numbers in the set. Moving on to 2, we only have 2, 2, 2, 3, and 2, 4 because 2 is not less than or equal to 1. It's not going to be included in our set. Starting at 3, we have 3, 3, and 4, 4, and then 4 only has the ordered pair 4, 4. To draw this relationship, we'll start by adding our vertices 1, 2, 3, and 4. And just like last time, I'm going to put in the loops before I add the directed edges. So I'll have 1, 1, 2, 2, 3, 3, and 4, 4. Then we can add the remaining edges. I need to go from 1 to 2, 1 to 3, and 1 to 4. Then I need to go from 2 to 3, 2 to 4, and then lastly, I need to go from 3 to 4. Let's try one more example. This time I have B is the set 1, 2, 3, 4, 5, 6, and R is A plus B is odd. So we'll write out our set and we'll write out the relation. We want to remember that A plus B is odd when only one number is even and only one number is odd. That means odd plus even is odd, even plus odd is odd, but odd plus odd is even plus even is even. This time when we write in our vertices, we're going to separate the even and the odd. I have the odds as 1, 3, and 5, and the evens as 2, 4, and 6. Next, let's think about drawing edges from the odd vertices over to the evens. From 1, I want to connect to 2, 4, and 6. From 3, I want to connect to 2, 4, and 6. And then from 5, I'm also going to connect to 2, 4, and 6. I can see that's 9 edges from odd to even. Each odd vertex connects to every even vertex with a directed arrow. We can reverse the pairs to add edges from even vertices. So this time, instead of going from the odd number, we're going to the odd number. So to get to 1, we'll add 2, 1, 4, 1, and 6, 1. To get to 3, we'll have 2, 3, 4, 3, and 6, 3. And to get to 5, I'll have 2, 5, 4, 5, and 6, 5. Because we're adding a biconditional relation, we can just change all of these single direction arrows to double-headed arrows. So remember, when you're drawing your graph, start with identifying the set, put in your vertices, make sure you have a list of all your ordered pairs, then draw the directed edges for each AB in the relation R.